I would like to start with my presentation. I'm the EIC Program Manager for Space Systems and Technologies at the European Innovation Council. So I'm just sharing my presentation. I'm really sorry, there is a hiccup, so I cannot share on full screen. But I would be quite, I started, let's say, I did my PhD on how to commercialize the Columbus module and worked at ESA Aztec as working exactly on commercial payloads in the early 2000s. In any case, I would like to tell you more and share with you my observations. These are personal observations on the lessons learned from commercialization of space technologies, what I have observed for the last 25 years. And also I would like to tell you a little bit about the European Innovation Council and how we help SMEs and startups to overcome the valley of death, a topic which Veselin mentioned earlier on. So let me go quick because I guess you're all tired, but it's very important to understand that developing, testing, launching, and deploying satellites are inherently expensive, delayed, due to complex test cycles, specialized suppliers, and launch prices. And there are a number of lessons I have observed in my career, initially in human spaceflight, later on in the domains of in-orbit satellite servicing, active debris, domains which I work closely in. So I've seen very often there are over-optimistic market estimates, and there is always a lot of people who say, oh, market creation is really easy. Well, no, it is not. It is really challenging. Time to market, sometimes, particularly from commercial customers, could be too long. And another trend which I see very often, particularly in countries which are full member states of the European Space Agency, is very often relying primarily on institutional customers. So it's extremely important to find the balance between commercial and institutional customers. Also, for certain technologies, there is often competition from terrestrial. Example, protein crystallization. You can do it often you can do it in ground laboratories. Why do you need to send an experiment in microgravity? And another issue, particularly for space stations and microgravity platforms, they have different value chains, different market segments, which might often confuse customers or investors. And also the current complex global macroeconomic environment could be quite of a challenge for companies. Other of that, I've also observed a number of innovation lessons. Changing end user requirements in the design and development, particularly at the early stage, could be a huge cost for the company. Or delay in the market entrance. I used to be a project manager doing flight qualification of power conditioning units at Thales in Belgium. And there often I realized that flight qualification and integration takes a lot of time. It's a long cycle, and there are a lot of issues. So it is very important, particularly for space SMEs and startups, and the so-called new space companies, to understand that. Another aspect is that very often we have TRL of low TRL, TRL 3 or 4, 3 and 4, which are not yet ready for commercialization, but they want to. And often when we see startups which fail to understand the complexity of space missions. Now, I've also want to share, these are all my personal observations, and they're not linked to the organization which I work, but I want to share with you what are the areas where I see that Bulgaria can develop, or areas which have emerging areas which are of importance in general. So space debris sustainability, as you know, is a major important aspect. So tracking, locating, describing space debris, space-based SSA, having AI and machine learning platforms to predict space debris collision, designing simulation models, and predicting particularly satellite anomalies, I do believe could be areas in which countries, as my country, could actually grow and develop. But another area which I do believe is in space robotics, extending the lifetime of satellites, and that we witness with the MEF-1 and the MEF-2 missions in the US. But of course, extending the lifetime also within space refueling. Other area, and before that we saw the presentations linked to space radiations, space radiation instruments, space weather, but also we should build on our historic competences. Bulgaria launched the first Svet laboratory on the Mir station. We have actually a lot of experience in space greenhouses or food. So all areas which could be quite beneficial for future cislunar and lunar missions. As you know, the country has signed the NASA Artemis Accord. So it's one of the major one of the contributors even before countries like Belgium. So that is my personal observations. But now I want to dive into what we do at the European Innovation Council and why is it so beneficial to be a partner in it, and how we help innovation driven by SMEs and startups. So actually the European Innovation Council is an executive agency of the European Commission. We do not do policy, we just implement, but we fund game-changing, high-risk ideas for SMEs and startups. And the beauty of the program of the EIC is that you have the Pathfinder open, which is for researchers, and top-down with challenges defined by the program managers as me. Once the Pathfinder project's finished at 3 to 4 million, they can apply then to the transition program, which is TRL4 to TRL6, and then accelerator, which gives funding up to 2 million, and beyond in equity up to 10 million. And there is also the STEP. But let me tell you about the space portfolio I manage. The space portfolio I manage has 3 pillars: space debris sustainability, looking at TETAs for space debris removal, in-orbit satellite servicing, enabling space technologies, Earth observation, and meteorology. You see here some projects which are producing solar panels, looking at producing solar panels in microgravity. What are the challenges, the topics? The last 3 years, I proposed the following topics. The first one is in 2023, Pathfinder, very low one, tier 1 to 4, where mainly research institutes, universities, partners are in space solar energy harvesting, how to collect the solar energy, how to beam it, and how to use it. And then we have also accelerate. Last year, we just closed the space debris sustainability call, which was about mitigation, but also remediation, not only with nets, robotic arms, but also tethers, propellantless removal, and how to use this debris. Is there a way to recycle it or reuse it? And this year, we have the one for innovative in space servicing, in space transportation, or orbital transfer vehicles, and also space-based resilience. So just a quick snapshot of some of the projects we have into the portfolio in space solar energy harvesting. You see we have very interesting projects on rectennas, on high power transmission rectennas, on sun pumped lasers. Also, we have projects on in-space refuel production, propellants on board, and so on. And the areas The emerging innovative space applications addressed are space-based solar power, ADR, in situ resource utilization, in-space refueling, and of course, in-space assembly and manufacturing. Now, quickly, I would like to just go through this year's challenge, because I can, if you are a European company or an associated member state, you can apply for the Space Challenge. The deadline is the 1st of October, and it's about innovative in-space servicing, operation, and space-based robotics. So why did I propose this challenge? Because current satellites are designed, built not to be serviced and repaired, and 85% are discarded due to fuel depletion. Also, often there is, due to increased debris collusion, there is shorter lifetimes of satellites, and we actually lack in Europe cost-effective, scalable, and resilient technologies to service and extend the lifetime of satellites. So this is the actual call. You can see iOS and maintenance, in-space transportation, orbital space-based resilience. One major point which I wanted to mention for the portfolio which I manage, particularly the in-space solar energy harvesting one, is that every year I also organize these webinars. And we had one webinar with JAXA and Kyoto University, also in Japan, particularly on the space debris, the CDR2 program. And then we learned also what are the research on space-based solar power in Japan too. So some conclusions. Space SMEs and startups can offer affordable, cost-effective technologies for in-orbit satellite servicing and ADR capabilities, which we can use for future lunar missions. As you know, as you see, there's happening some commercial missions. These companies need to be aware of these historic commercialization lessons and look at the technical, operational, market risk to be prepared in this risk-averse environment. Thank you very much for your patience and invitation. Truly appreciated.